Yes. So we will start from yesterday's class onwards. Okay. So let us start with yesterday. Where did we stop? We stopped at magnitude or multiplication of a vector by a scalar, right? Multiplication of a vector by a scalar, correct? We stopped at this, correct? So now what we will do in this, one of the things I have not told you, that when I said AB, A into A, okay, A is a scalar, this is a vector. Magnitude of A into A is equal to A into magnitude of A, correct? So magnitude of this is that, okay? Then another thing, direction of A into A, this direction, okay, is equal to direction of A, correct? Very important. A vector, A into A is equal to, that means direction does not change. That's what we said. When we multiply a magnitude, direction does not change. In fact, that is not entirely true. Why it is not entirely true is because it is true when A is positive, okay? Only when A is a positive number, okay? And if A, small a, is a small a is a negative number, if small a is a negative number, then the direction reverses. The direction reverses. Very, very important. So direction of this will reverse. So what happens? Minus of a minus a, or if this is a negative number, okay, this direction is equal to minus a unit vector. Make sense? So multiplication of scalar, so multiplication of scalar with vector causes, first is scaling. Scaling means making it bigger. What is small, if it is 2, it will become bigger, okay? Scale of a is equal to 2. If a is, this is a, okay? So this is capital A, this is 2a, I can say, okay? And this one, if I say this is 0.5a, correct, that is 0.5a. Make sense? And another thing it can happen is it can reverse the direction. If it is like this, it may happen like this, minus 1 into a, okay? So scaling and a reversal of direction, and a reversal of direction, reversal of direction, if the scalar has a negative magnitude, has a negative sign. If the scalar has a negative sign, then what happens? It will reverse the direction. Make sense, students? Write this down. Any doubts you can ask. Tell me when if I fast, if I'm fast, okay.
Sir, done, sir.
One. Okay. There is
Hello,
one
sir.
question. Yeah, there is
Wait,
one.
wait, wait, sir, wait, sir, 1 minute.
Okay, okay. There is one question by one Vishal Kosti, is from the Anand Sagar College. Okay, so he's asking, can I write, sir? Can I write mechanical and join aerospace? Okay, answer is yes. Actually, mechanical has more scope in aerospace. In the sense, if you do MTech, if you want to do MTech in IITs, ME Gate is given more preference than Gate Aerospace. Okay, so ME Gate rank has more importance than aerospace engineering gate. A mechanical engineer can write aerospace engineering gate as well as mechanical engineering gate. Okay, but mechanical engineering gate has more weightage. Out of 18, 7 are for mechanical engineers. It's reserved for mechanical engineering gate. So there's a lot of things, students. Okay, and mechanical engineering as a branch, as well as a as to go get into higher studies. Okay, has the highest strength among all the engineering subjects. In terms of that, you can go to anywhere. Okay, mechanical engineer can do computer science, provided he has to write computer science engineering. Okay, computer science gate, if he writes, he can get into computer science MTech. But a computer science BE cannot get into mechanical engineering by writing mechanical engineering gate. Okay.
Hello, sir.
Done? Very good. Okay.
Hello, sir.
Yeah.
Sir, in the second line, you have written a vector, then cap. So
Yes.
can you put like that, or only we should put cap?
Here A vector. Yes. Yes. Only cap. Correct. Correct. Only cap. Very good. A cap. Direction of that. Is it not? Fine. Done. Next one. Next thing. These are all important things. Sometimes I forget these things. Okay. Next one is addition and subtraction of vectors. Addition and subtraction of vectors. Let us see how to do it. Okay, so now in case we have to add two vectors, okay, one of the things we can use is this parallelogram law. 1 second, students, let me open up the 1 second, just a second, just a second, students. I'll just come one short thing. Okay. Okay, so now when you add two vectors, it is not simply adding magnitude and direction. So if I have a vector, say A is equal to AXI plus AYJ plus AZK, and then if you have B which is equal to BXI plus BYJ plus BZK, this can be simply added as if I say A plus B is equal to AX plus BX I plus AY plus BYJ plus AZ plus BZK. Very simple. We can add it this fashion. Okay. Then there is another way. This comes as also as a parallelogram law. What is that parallelogram law? If you have a vector A, for example, and then a vector, so let me use this as A. this as B, and this as A. If I use the vector A and B like this, okay? If these two represents the sides of a parallelogram, if these two represents a sides of a parallelogram, and I can always have it this fashion, okay? And the direction of the diagonal represents A plus B, both in magnitude and direction. What does that mean? It means that A plus B magnitude, which is equal to ax plus bx the whole square plus ay plus by the whole square plus az plus bz the whole square and square root of that. That is equal to magnitude of this particular thing, which is coming the same thing. Okay, so if you take this vector, say a plus b is equal to c, a plus b is equal to c. That means this is equal to square root of cx square plus cy square plus cz square. Make sense? Okay, that is what is the way we can write vectors. That is addition. Okay. Now another point here is this is commutative. That means vector addition, vector addition is commutative. Vector addition is commutative. Means what? It means A plus B is equal to B plus A. This is the basic definition of a vector, is it not, students? If the vector is not commutative, it cannot be a, if the addition is not commutative, it is not a vector. Example is our angle, is it not? So in the angle we have seen, if it is not a, it's not commutative, it is not at all a vector. Okay, same thing holds good here. Now there are various applications for this. One by one I will tell you, okay, how the applications are there of this. Then we will derive parallelogram law, students, okay. So today we will continue till 11 only, okay. Afterwards we will start with the at 11:30, or we'll go to 11:30. That's better, okay. We'll go with 11:30, and from 12 to 1:30 we will have limits, okay. Students, for gate, you need to have full amount of full-fledged commitment for this, okay. Only then you can score that high ranks, okay. And here we have demonstrated how high ranks can be got, okay. This time I'm planning for at least one first rank, which is possible, okay. We are giving all the things which is required to score first rank in gate, and you are in no competition with people from IITs and NITs. All are private engineering colleges competition, is it not? NITs are there, but very few. Okay.
Done, sir.
You're done. Okay. So one more point. Okay. Another point here is, let us see parallelogram law. Very, very important. Parallelogram law. Let us see how it works. Okay. So now, if I have, say, a parallelogram, if I have a parallelogram, say this is P, and one side is represented by a vector P, and another side is represented by vector Q. Let us complete the parallelogram. This is the total parallelogram I can have, is it not? Okay, this is the total parallelogram I can have. Okay, so now let us see. Let us drop down a perpendicular here. Let us drop down a perpendicular over here, and let me drop here like this. Okay, this is one perpendicular over here. Correct. And let us say the angle between P and Q is theta. Okay, angle is theta. And then we have a line. What do we say? This line represents P plus Q. This is parallelogram law stated. Okay, already stated that this line represents the addition of vector. Now let us understand this. Let us refer this as the origin O. Okay, let us say this is A. Okay, this point we will call it as A, this particular point. Okay, then we will call this as B, this is C, and this is D. Okay, now let us see. Now if you consider OD, OD can be written as OA plus AD. Make sense? OD is equal to OA plus AD. Correct, students? Similar way, I can also write OD is equal to OA plus. Now observe here, OB is equal to AC. Observe, OB is equal to AC. Make sense? So what is AC? AC, when you say, is equal to Q, which is equal to Q. Correct? And this is theta anyhow. So AD can be written as Q cos theta. Make sense? So I can write OD is equal to OA into Q cos theta. I can also write this as, since OA, okay, OA is P, OA is P. So I can write OD as equal to P plus Q cos theta. Makes sense? This is one side. Now let us take DC. What is DC, students? DC can be written nothing but Q sine theta. Make sense? This DC is equal to Q sine theta. Make sense, students? Correct? No doubts here? Okay. Now, again, let us say OC square, because we have to find OC square. Okay. OC square can be written as OD square. Observe this, OD square plus we have DC square. Makes sense? Because it is a O, D and C. O, D and C is a right angled triangle. Is it not, students? So I can write from the Pythagoras rule as OC square is equal to OD square plus DC square. Now what is OD square? OD square is nothing but equal to P plus Q cos theta the whole square plus, here we have Q square sine square theta. Let us open this up. When you open this up, you get P square plus Q square, P square plus Q square, okay, cos square theta plus 2 PQ cos theta, PQ cos theta plus Q square sine square theta. Now this can be written as p square plus 2pq cos theta plus, here we can write q square into cos square theta plus sine square theta. Makes sense? So this can be written as p square plus 2pq p square plus 2pq plus q square. Correct, students? Sorry, 2pq cos theta, 2pq cos theta plus q square. What is this OC? What is OC? OC is p plus q. Is it not, students? It is p plus q the whole square. Correct? So now further going with this, I can write that the magnitude of p plus q, the magnitude of p plus q can be written as square root of magnitude of p square plus 2 times magnitude of p magnitude of q cos theta plus magnitude of q the whole square. This is very important. This is parallelogram law of vector addition in algebraic form. Okay, so what is it? I'll write again here, students. P, this whole thing you can see, is it not? So P plus Q, P plus Q is equal to square root of, okay, P plus Q magnitude, very important. P plus Q magnitude is equal to P square plus 2 times p q magnitude cos theta, okay, plus q square. Make sense? So this is very important, students. This is very important. You may be asked to derive this also in interviews, so you have to be careful with this. Okay, yeah. Step by step, slow and steady. Okay, and one of the things you may have problem, students, you may think, sir, if I sit for 8 hours of class, what will I study? That is one of the mindset students will have. Don't worry, sit for 8 hours of class. Okay, what will happen is when you sit there, you are grasping something. Okay, and then whatever 3-4 hours is there, you just flip the pages initially, especially within, now today you may feel it's very interesting, okay, but within around 25-30 days you may be overwhelmed by the amount of knowledge, amount of information. You will be overwhelmed. Okay, you will say, oh, ಇಷ್ಟಿದೆಯಾ ಏನ್ ಮಾಡೋದು ಈಗ ಅಂತ ಅನ್ಸುತ್ತೆ ಆಯ್ತಾ. So at that time you should have patience. Okay, you should not worry at all. Continuously do the work, and the person who continuously does work will succeed. And this feeling is there with everyone who starts. It's not just with you. Anybody who does within 1 month, okay, he'll be overwhelmed, and he'll feel gate ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ ಅನ್ಸುತ್ತೆ ಆಯ್ತಾ. ಅದನ್ನು ಮೆಟ್ಟಿ ನಿಲ್ಬೇಕು. ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಮೈಂಡ್ ಸೆಟ್ ಅನ್ನು ಮೆಟ್ಟಿ ನಿಲ್ಬೇಕು. I don't know how many of them are not from Karnataka. How many are not from Karnataka? Let me see. I think everybody is from Karnataka here. Anybody who cannot understand Kannada? Sheldon. Anyone who cannot understand Kannada? I think Gyanendra a bit. Gyanendra is there? Yeah, Gyanendra. Gyanendra, you can understand Kannada?
Yes, sir. Yes, sir.
Yes, very good. ಸೊ ಅದನ್ನ ಮೆಟ್ಟಿ ನಿಲ್ಬೇಕು ನಾವು. ಆ ಒಂದು ಮೈಂಡ್ ಸೆಟ್ ಅನ್ನು ಮೆಟ್ಟಿ ನಿಂತ್ರೆ ಮಾತ್ರ ಆಗುತ್ತೆ. Okay, this has to be recorded, so I cannot talk in Kannada also. I'm sorry. Because in the mother tongue, you know, it becomes very easy. Okay. And let me tell you, students, one of the mindset we have is in IIT, all have good English, are very intelligent. No, you've seen Shiv Mahant, is it not? Shiv Mahant is not that good in English. Our Manoj sir, not that great in English. We are all good in engineering. Okay, very important. The people who go to IITs are very good in engineering. Most of them are from rural backgrounds. Okay, not the IIT BTechs. I'm telling you about IIT MTechs. Okay, and we are the people who are running the nation. Keep in mind, it is not the IIT BTechs. Why? IIT BTechs go out of India generally. Okay, and they have scope. Okay, but when you consider private engineering college students, okay, even if they go out of India for doing MS or anything, okay, they don't have much scope, students. Okay, why? Because they are as say similar to the people who are there in that nation. For example, if you go to Germany, if you go to United States, okay, IITs are superb. That's why they get the job. Okay, we are as similar to anybody else. Okay, so the maximum scope we have is in India, not outside India. Okay, but we have to learn the basics properly. Okay, if we don't have the basics, if we go below par, then no scope. It is like I was talking to some of the people here, local people. Okay, so some people say, sir, bank exam, is very difficult. Okay, previously all the banks started in Mangalore only, and now in banks we don't have Mangaloreans, and we struggle to get into Mangalorean banks. See, one of the mindset we have to understand is it is nationalized, whether it is MRPL, whether it is Canara Bank or say Syndicate Bank or any banks which have started from in and around Mangalore. Okay. Now these are not the properties of Mangaloreans now. It is all India. And when it is all India, you have to go with the competition. And sometimes we feel that we are much better than others, is it not? If you think that you are much better than others, prove it. Okay, my thing is that we are as good as any other place in India. My humble know-how is this, that intelligence is equally distributed in every places. Awareness may be different. Intelligence is same. Whether you go to say Kendrapada in Orissa, Kendrapada is one of the what do you say, one of the most backward districts in India. Okay, if you go to Kendrapada also, there also the intelligence is same as us. They might not have opportunities. That's it. Okay, they might not know it. That's it. Okay, but the intelligence level is almost the same. Okay, they might not be talking in good English. That is one side. Okay, so we have to learn to be humble students as much as possible. Done? Tell me when you're finished, students. We'll go for the next.
Yes, sir.
Very
Done, sir.
good. Done. Very
Wait,
good.
sir, wait, 1 minute.
Okay.
So one doubt.
Yeah.
In one of the steps, it's like q square bracket cos square theta plus sin square theta. That q square should be vector, right?
Yes. Very good. Correct. Q
Okay.
square. That is equal to magnitude square. Correct. Here also Q square must be a vector. Correct. Good observation. If you want, we can put vectors here also, students. Magnitude of this vector. That would be 100% proper to write like that. Okay. Sometimes we assume things. Okay. We skip see these things, and that is common with me especially. Okay. So everybody has some or the other weakness. My weakness is not to see details. Okay. Attention to detail. Sometimes I lack. Okay. Fine. Once you finish, you tell me, students.
Sir, one doubt, sir.
Yeah, please.
Sir, you told that the resultant gives the diagonal gives the resultant, no, sir.
Correct.
Like, how can you say, sir, that it will give the resultant?
How can you say it gives resultant?
Diagonal only will give the resultant.
Okay, diagonal will give the resultant. You say why it gives the resultant, right?
Yes, sir.
That's your question. Okay. Then we have to do a force balance and we have to see. Okay. Let us do one thing. Okay. After this, we will go with resolution of a vector. Okay. When we resolve a vector, we will solve. We will see how the things has to be done. Okay. So
Okay.
that time I'll explain you why that diagonal will actually give the magnitude of a vector.
Okay, sir. Okay.
Okay, so after that is done, I will tell you. Okay, so because what happens, see all the questions, this is a very good question that you have asked, and this has to be answered. Why? The question is why. Why is that we have it here? Actually, what we have to do is we have to put a, and you know it is it. You have to put a perpendicular here. You have to drop a perpendicular here. Okay, you have P here. Okay, you have Q here. Okay, this becomes Q. Okay, this is P. Okay, then you say you take this alpha, this angle. Okay, you take this angle. Okay, then you will see P uh, cos of this one and this one will actually give the resultant, okay, of both the things. That is one way of doing it. Okay, it's a very basic question, student. Okay, wait a minute, let me try to answer that. Okay, the question is why is that? Okay, I have told you that parallelogram law says that if two sides of a vector is represented by two sides of a parallelogram is represented by vectors, then the diagonal represents the resultant. Okay, that's what I said. Okay, one thing we can do is we can do experiments and we can see. We can do like this. We can pull a particular what do you say? Okay, let me explain that. Okay, let me explain that after I complete something. This I'll keep in mind. Okay, after we do some concepts, then I will explain you why this is there. Okay, so good question. Who is this person who has asked this question?
Sagar, sir.
Sagar, very good. Okay, now what we have not answered is why. Why is it that parallelogram, the diagonal represents the resultant? Okay, we will answer that in a moment. Okay, fine. Let us continue. Now we are not clear. Okay, we have some haziness here. Okay, yes. No, your sound is not clear, Mister. Who is that speaking?
The previous slide, Ashutosh. Sir, in the previous slide, sir,
Ash.
you have written summation of two vectors. This ax plus bx I cap.
Correct. That is one of the way.
So,
Yeah. Correct, Ash.
no, then it must not be valid, right?
Huh?
According to, no, according to parallelogram law or the other law, then this
Hmm.
must be wrong, isn't it, sir? Because
No, it
ax
is not
plus
wrong.
bx I cap. No, how the no magnitude? No, I guess root ax plus bx whole square.
Hmm.
Root of that has to be the answer here in I cap, isn't it? What should be? I guess the second statement might be wrong. So
This one is wrong. You say?
maybe so. No. About that, a plus b equal to ax plus bx I cap. This one that might be wrong.
Yes, yes. This is wrong. This is like this. Is it not?
Yes.
Correct. Okay. The magnitude. No, 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 no.
It's correct, sir. It's correct.
It's correct only. It's
Is
correct.
it?
It's correct only. We will see that later. We will see. We will do examples and then we will see. Okay. Let us see that. Okay. This is correct only. We will see it in a moment. Okay. How is that? Okay. This is a good
Yes.
discussion, students. I'm happy that you are bringing up new things. Okay. This is how it has to be. Okay. Good. So today with the Shivman sir, I told that my students are very good. Okay. And you're proving it. Okay. Thank you. Okay. Let us go further. Okay. This is how inquisitiveness has to be there. Even if I answer, I don't answer, I will answer for sure. Okay. But this discussions has to come. Okay. Now, students, we have got the magnitude. Observe here, we have got the magnitude of P plus Q. Next step is we have to get the direction. How to get the direction? Okay. Now, when you have P here, I'm sorry, when you have P here and then Q over here, P and Q. Okay. And then we have it like this, is it not? Okay, we have it this way. Okay. Now, this angle we said is theta, correct? Now let this angle, we have to find where the resultant is. We have to find the direction of the resultant. How do you find out the direction? How do you specify the direction of the resultant? It is at some angle alpha from Q or some angle beta from P, correct? That's how we have to say. Now how can you say the angle alpha? Now the angle alpha can be written, say this is O, this is A, this is D, this is C, and this is B. This is how we have put it, right? So we can also say, we can say tan alpha to find the angle, okay, to find the direction, to find the direction. To find the direction, we can say tan alpha is equal to dc, dc by OA or DC by OD. I can say that. I can say DC by OD. So I can say tan alpha or alpha is equal to tan inverse of Q sine theta divided by P plus Q cos theta. Very, very important. Okay. Alpha can be written like this. Alpha can be tan inverse of Q sine theta divided by P plus Q cos theta. Correct? Because this we have derived. Correct? Similar way we can do other things also. We can also say in terms of this is resultant. You say this is R, resultant magnitude you get. Correct? So you can also say alpha is equal to sine inverse of Q sine theta, Q sine theta divided by square root of P square plus Q square, or we will write it as R, okay, divided by R, divided by the resultant. I can write it like this. Or we can say alpha can also be equal to P plus Q or cos inverse of, I can write it as cos inverse of P plus Q cos theta, P plus Q cos theta divided by the resultant R. What is the resultant R, students? Resultant R is equal to P square plus Q square plus 2PQ cos theta and square root of it. Make sense? So these three equations, depending on what is given to be solved, you can get these students. Make sense? Depending on what you are using, you are going to do this. Make sense, students? Hello?
Yes, yes.
Very good. So super. Okay. So this is one of the way we can solve. We can find the directions. Okay. Write this down, students. Tell me when you're finished. Okay, I'm here only. Done, students?
So that should be magnitude of R vector last.
Exactly correct. Magnitude of R vector. So this also is magnitude of R vector. All these are magnitudes. Okay. Everything is magnitude here. Very important to put magnitude. Sorry. Everything represents magnitude, students. Okay. We have to be proper, is it not? Just a second. I'm here only, students. Okay. I'm just taking one book. That's it. So there is a book by Sham series. Yes, it's over here. Anyhow, so there's a book by Sham series. We will see that. Okay. So in that also there are number of questions which are there. Okay, which is good enough. Okay. So we will solve some questions. Student, Sham series is one of the good books. Okay, you don't have to buy it. Everything buying is difficult. Okay. If you have access to some library, you can take that. So I use Shane's, okay, and questions I use Sham series, okay. Done, students?
Done, sir. Done.
Very good. Okay. So now another point here, very important. Okay. When you consider, let us take one example. Okay, just to say that. Okay. Say for example, let us have. Okay. Um, See, one of the troubles we may have is the direction may be different. For example we will take an example. Okay. If you take an example of, say, there is a vector, say, of 5 Newton on this side, okay, and this side there is another vector, say 10 Newton, okay, 10 Newton working on this side, okay. What is the, what would be the magnitude and direction of the resultant vector? Okay, find the magnitude and direction of the resultant. Very simple, students. I know you may feel it's very simple, but still we will do it. Okay. So let us take what is the resultant. This is the resultant, is it not, students? This is the resultant R. Now we have to find the magnitude and direction of this resultant. Can we do it? So first of all, to find out magnitude, what you do? R is
Sir,
equal to,
could you go to previous
you can
slide?
see this angle is 135. Okay. Yeah, tell me.
Could you go to previous slide?
Yes, very much.
Sir, that is tan inverse of P sin theta by Q plus P cos theta, no?
DC is Q sine theta, is it not? What is DC? Q sine theta. Tan is opposite by opposite by adjacent, is it not?
Yes, sir. But in this diagram, Q and P has been interchanged.
I'm sorry. I'm very sorry. I'm very sorry. Very sorry. My bad. P here, Q here. Kindly change it, students. It was the
Sir, in
original.
previous slides, while deriving for P plus Q cos square theta, those P and Q should be in magnitude only, right, sir?
Exactly. Yes. Yes. Yes.
Those all
Everything
from
magnitude.
starting.
Yes, 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 yes. We are assuming it, okay, but everything is magnitude only. It is not vector, okay. It's very important. It's magnitude, okay. Everything should be magnitude only if you talk strictly. But sometimes we make a what you say, when we solve, we will say, okay, why should we write all everywhere here like this? So let us say that is it in our mind. It is there. It is magnitude, okay. So sometimes we become lenient. So put magnitude for everything, students, okay. In a strict sense, it has to have magnitude everywhere. It's magnitude only. We cannot talk about vector there because we are not talking about direction. We are talking only about magnitudes. Correct? Make sense? Student, does it make sense? Correct? Okay. Similar way here, P and Q. Yes, my bad. I changed this here and there. Okay. Now let us understand this. Okay. So this vector R. What is R? R can be written as P magnitude square plus Q magnitude square plus P Q cos theta, correct, into square root of that. Let us put that. What is R magnitude? R magnitude comes as 10 square plus 5 square plus 2 into 10 into, say, 2 into 10 into 5 here, 2. I'm sorry here, student, there's a 2 here, 2 PQ, 2 into 10 into 5, cos of 135. Cos of 135 and square root. Now observe here, there will be a minus here. Observe, there will be a minus here. Correct? Cos of 135 means there will be a minus. That also means that the q could have been taken in some other fashion also. Okay, we could have put this 5 here. What is cos 135, students? Cos 135 is, how does cos 135 cos comes? Cos 135 is minus of cos 45. Is it not, students? Cos 135 is somewhere here, correct? It is minus of cos 45. Is it not, students? Okay, so that has to be understood. So the same thing can be changed into triangle law. Now what is parallelogram law can be changed to triangle law. How is that? I will tell you. Okay, so this now comes as being equal to, if you do the math, you will get it as 7.37 Newton. So the magnitude of R is 7.37 Newton. Okay. Now the same thing, if you say this is A, this is B, this is C, and this is D. Now same thing can be written as, you can say 10 Newton over here. We can say 10 Newton over here. And then we can take 5 Newton over here like this. Very important. We can take 5 Newton like this, with this being A, this being B, this being C. And then I can say R over here. I can put R over here. I can put R over here. Okay. And then I can say here, this is 45 degree. Makes sense? This is, when this is one, this we do not know. Alpha we do not know. This is 45. Anyhow, we know it because this is same. Correct? So now here also we can put PQ rule, but one of the main thing here is, here when we put here, the R will change to, in case of triangle law, okay, this is parallelogram law. Here when you go to triangle law, okay, when you go for triangle law, okay, what happens in this case, alone, okay, so we have to see how the things are, and depending on that triangle law, my R becomes equal to square root of P square plus Q square plus, instead of plus it is minus 2 PQ cos theta, where cos theta is the angle between two things. Got the things? This is triangle law. There is a minus here. Theta is the angle between P and Q. Makes sense? The same thing happens the other side also. If you consider, let us take this here, okay, say in this fashion, if you take this is P and this is Q, if I say, no, how was it? Let us follow the same thing here. What was P and Q? P and Q, yeah, P and Q was the other way around, correct? So let us take this as P, this as Q, correct? That's how it was. So when you take it this way here, Q, and then you have it here, okay, then what is PQ? What is the angle between, because this theta, and then whatever minus is there, because theta is more than 190, this comes negative, and it comes to the same parallelogram law. So if it is a triangle law, you have to have a minus. If it is parallelogram, you have to have plus. Make sense? Make sense, students? So triangle law, there is a minus. Parallelogram, there is a plus. And the same thing you do, you will get R magnitude is equal to square root of 10 square plus 5 square minus 2 times 10 into 5 into cos 45. Makes sense? Very important. And this comes to be 7.37 Newton. So you can either take triangle law or you can take parallelogram law. We have to understand how does it form. Okay.
Sir,
So
what about angle? Is it the minus 135 in first figure?
here in this case,
Yes, sir.
you are telling in terms of clockwise and anti-clockwise, is it not? Sir, this is going anti-clockwise. This is positive, correct? So 135. Why should it be minus?
Yes, sir.
It is anti-clockwise, is it not?
Yeah, no. Oh, it's plus. Okay, sir. I thought it's minus 135
No, it's not minus
in figure.
135. The angle, I was putting the place there like this. Okay, I was putting just like this. Okay, the line there. Okay, it's 135, not like this. Okay, it's 135 alone. Okay, yes, makes sense.
Yes, sir.
Good. So triangle law minus parallelogram law plus has to be there. Okay, then accordingly. But how to say whether it's triangle or parallelogram law? See, if the what you say ends, if the what you say, if the base of the arrows meet, there you are applying parallelogram law. If one arrow is on the base of the another arrow, then it is triangle law which has to be applied. Make sense? Make sense, students? See, this closes, the R closes here. Observe, this is in one direction, this closes. This is very important. This particular thinking is very important when we consider acceleration diagram. In acceleration diagram, whether it is kinematics of machines or whether we take say dynamics of machines, where you have to get the centrifugal accelerations, okay, or centrifugal forces, for example, balancing of rotating masses. These are very, very important. And obviously in trusses, okay, wherever we go, structures, trusses, this direction of forces matters a lot. Okay, yes, I will written this down. Find the angle, please. Find the angle. Find the angle between the resultant and say 10 Newton. Find the angle between resultant and P. Okay, say this is Q. Find the angle, student. This is your work you have to do. Tell me what is the angle. Yes, do it fast. Put pen on paper, practice. Okay, you have to do it by yourself. Students, kindly inform your friends also. Okay. and everybody is going to get benefited out of this. Okay, all the problem of joblessness will go. Okay, either you'll get placed within few days. I'm not giving you any interview to say tips or interview in the sense I'm not going to place you somewhere, but whatever your efforts you do and get interview call, in the interview you'll clear. That is the main thing, because of the knowledge what you're getting here. And previously also a lot of students have cleared. And yes, if I get some notification saying that some of my friends say that there is some vacancy in some of the engineering firms, I will obviously share it with you. Okay. And don't go for just a job, students. Go for a career, very important. Once you go for a job, you'll just get stuck there. Done, students?
Yes, sir.
What is alpha? If it is done, you have to tell me what is alpha. What is alpha? Alpha is this angle. Correct. Tell me what is that angle alpha here. The angle between P and the result. This triangle law is very important, students. Very, very important. Done? Tell me what is alpha.
So 28.
Very good. 28.6 degrees. Very good. So I hope everybody has got it. Okay. 28.6 degrees. That is the angle of alpha. Done, students? Can we move further? Okay. Next point. Now, this angle triangle law can be applied for geometry also. For example, if I have a geometry saying that, say this is angle alpha, this is angle beta, and this is angle gamma. Okay, and say this is side B, this is side A, and this is side C, side length. Okay, this is of length B, this is of length A, and this is of length C. I say that these are all basic, students, we might have lost it. Okay, so if you want to find out B, so B square can always be written as A square plus C square minus 2AC cos of beta. Very important to remember, this may be helpful, handy in a lot of number of written tests. Okay, similar way, if you want to have A square, what is A square? A square is equal to B square plus C square minus 2BC. 2BC. Sorry, this is cos beta. I'm very sorry, student. There's a mistake here. This is cos beta between A and C, and this is cos alpha. Then similar way, C square is equal to B square plus A square minus, sorry, this is not alpha, it is cos alpha. Cos alpha into 2 times BA cos gamma. Make sense? Make sense, students? Write this down. Very, very important, used in a number of situations. We sometimes are not able to solve some complicated problems because we don't know these basics. So recall these basics, students. Another point, even for this triangle, there is a law of sines. Law of sines for triangle. What is the law of sines? We can say A by sine alpha is equal to B by sine beta. that is equal to C by sine gamma. Very important. C by sine gamma, A by sine alpha, B by sine beta. Opposite angles. You see, the opposite angle to A is alpha. The opposite angle to B is beta. The opposite angle to C is alpha. Observe that. Okay. Like this. This you know, students, you have done in PUC, but you might have forgotten. That's it. Very important to remember these things. And step by step, when we do, you will feel that how, and all the competitive exam, these are the questions which are asked. Okay. Any other person? Somebody has. Yeah, Aditya has asked a question. Lamis theorem. Yes, Aditya, it is Lamis theorem. It is Lamis theorem. How Lamis theorem comes, I will tell you.
Yes, thank you.
Yes, it is Lamis theorem. Next step is Lamis theorem only. So step by step we are going. Are you appreciating the way I'm opening up the concept, students? Everything is done in a short time. Although I am what you say, you think that I am going slow. I am not going slow. I'm telling you all the relevant things. Okay, step by step I'm going. Okay, because I don't have to do like PUC, right, where you say a question and you do 10 problems later on. That problems you can solve it by yourself. Okay. Let us do some problems also, but not as much as we do in PUC, because otherwise the whole class will be that only. Okay, so we are touching upon everything. Okay, and gate problems we will do a lot. Okay, gate type of problems. Students, kindly register as soon as possible. Okay, if you are happy with the way we are going, and you have decided to prepare for gate, please register. Okay, you have to send say that you are going to register, then I will send you the payment link. Okay, so initially you have to pay 15,000 rupees as the initial installment. Okay, next to 10,000 installment you have to pay. Okay, or you may choose to pay 35,000 at once. Both things can be done. I'm very happy if you choose at once, but you can pay in installments also. Okay, yes. And these classes will go from, say, today is from yesterday we have started August 16th. We may go till December 15th. That is the time we are taking. August, September, October, November, December. 4 months. 4 months of extensive 8 hours a day, or 7 to 8 hours a day. That I'll put it like 7 to 8 hours a day, excluding Sunday. But sometimes we will take on Sunday also, because our Murli Bodla sir is sometimes having his own what you say duties there. Okay, so he may take on Sundays also. Okay, and I don't want to miss such luminaries from taking the classes, because he's such a what you say industrial expert. Okay, so you will see, and I'm not telling any style to him. He will only do his in his own way. Okay, but you can always ask questions, and if he's faster, you can reduce the speed. Okay, you can make him reduce the speed. Okay, yeah. But he's not speed for sure. Okay, because we are all the people who want conceptual knowledge. Okay, yeah, and we can reduce the speed like anything. Okay, like today Shiv Mahant was going very slow. Okay, he was thinking about his college students. Okay, he's working in REC Hulkoti. Okay, so he was thinking that my students are so weak, so I go generally slow. That is the mindset they have. Okay, and you people are much faster than them. Okay,
Done, sir.
yeah, very good. Okay, another point. Now this is actually Lami's theorem, as our Aditya said. Okay, so what is happening? We have same thing. Let us see how it goes to Lami's theorem. Okay, so we have this as alpha. How was it? It was, this was beta, I'm sorry, this was beta, this was alpha, this was gamma, correct? Now let us take, say, let us take O, A, say O, okay, let us take this as ABC. Okay, let us take this as capital A, capital B, and capital C. This is small b, this is small a, this is small c. Now what we will do, we will move this. There is a stick AB. We will put the stick AB here. Okay, this is the stick AB. Okay, then we will move BC over here. Okay, this is AB. BC, we will move that stick from here. We will put C to A. Okay, so CB comes here like this. Okay, so let this be CA. Okay, so CA, I have got it here. Then the same thing, we have BC. That BC, I will bring it over here. Okay, so it is BC. Observe that. So let us take it like, instead of doing it like this, let me call it as O instead of A. Okay, so everything I brought to a particular place, O. Okay, so this one, okay, is here. This is A. Okay, this is A. Length will, we will see, this is A. Then what is C? C is this. This is B. Correct. We have moved. Let us not confuse with this number. Okay. So we have moved like this. What are the angles? Let us see. So if I see here, okay, this angle, okay, this angle, okay, from say over here, okay. So here, let us take like this. Okay, let us take this way. Let us take this way. Okay. So now observe. Okay, if I take B over here, okay, B over here, okay, this angle here, let me put it over here like this. Let it put it over here like this. Okay, so now if you consider this angle is gamma, makes sense, this angle is gamma. Similar way, now here, that is one side, this is gamma, fine. Then beta is coming here, B is coming here. Okay, let us take this, this is alpha, makes sense, that is angle alpha. Okay, and then we have alpha is done, this is done. Okay, now next we have this angle is beta. Okay, now if you understand, now what we have this as, say, observe again. Okay, let us take, okay, uh, A by sine alpha is equal to B by sine beta is equal to C by sine gamma. We know that sine 180, okay, sine 180 minus alpha is equal to sine alpha. Agreed, students? Sine 180 minus alpha is equal to sine alpha, is it not? So let us write this as similar one. I can write this as A of sine of 180 minus alpha. I can write it as B by sine 180 minus beta, and this I can write it as C by sine 180 minus gamma, right? Now observe what is 180 minus gamma. Let us put that. Okay, so you see from this point to till here, okay, let us take this here. Okay, it can be reduced to, say, if I have three angles here, let us have three angles. Okay, so this is B. Okay, it can be reduced to this particular, is sine 180 minus alpha is equal to alpha, students, sine alpha. Is it right or am I wrong? You say whatever I say is right, students. Don't do that. Okay, so if I say 180 plus alpha, sine 180 plus alpha is equal to sine alpha, I'm very sorry. Okay, so here if I say this one, you come here, right? This is 180, right? Sine 180 here, right? Alpha plus 180 is equal to sine alpha, correct? 180 is equal to sine alpha, correct? Okay, am I right? Come on, students, help me out. Okay, so this is alpha, this is 180 minus alpha, correct? Only this is minus alpha. Okay, so 180 minus alpha, correct? Okay, so now it will so happen that if I say this is, say, angle alpha, beta, gamma, then what we have? Okay, we can say this is A. Okay, sorry, this is B. I will say angle capital B. Okay, and I will say this was C. This is angle capital C, and if I say this is angle capital A. Okay, then what happens? This will also reduce to A by sine A plus B by is equal to B by sine B is equal to C by sine C, where C is this angle is C, this is C over here, correct? This is A, I'm sorry, this is A, this is A. So A by sine A is equal to B by sine B is equal to C by sine C. It will reduce to this particular thing only. Observe that, okay? Because whether here, let me put it proper here. Okay, one second. So if I say, okay, if you observe here in this fashion, I will say this line you observe, students. Okay. No, there has to be a bit more derivation, students. Okay, I have not done that derivation. Okay. Okay, this is 180. Observe here. I will use this one. See, this angle is 180, correct? So if I consider, and this is alpha, correct? So one second. This is A, correct? And what is alpha? One second. I made a mistake with alpha, students. Okay. Okay, anyhow, this is Lami's theorem, students. We will not, I have not done the derivation properly. We will miss it. Okay, not required. This is Lami's theorem. Okay, similar to that, they can be derived, but I don't have the derivation now. Okay, it can be derived from this rule only. From this only we can derive this. Okay, so I am missing some small points over here. Okay, but not required. We can directly write what is Lami's theorem. Okay, so here what has to happen? Opposite angles has to be taken. Okay. Let us do the next problem. Okay. Sorry, today I'm not very good, is it not? Okay. Anyhow, write this down, students. And I know you have not understood the things here. There is some small things I have missed here. Okay. How to go from this particular thing to here. Okay. Okay, let me not try this. Okay, let me not try this now, but write the Lami's theorem. That's more than enough. Okay, C by sine C, B by sine B, and A by sine A. Make sense, students? Next, let us go with the resolution of vectors. Okay, how much time do we have? We have 20 minutes, 10 minutes remaining. We will do resolution of vectors now. Done, students? Have you written it down? Hello?
1 minute, sir.
Yeah, please. I got it now. Very important. Students, I got it now. I'm very sorry. Okay. See here. This is this angle. What is this angle? This angle is 180 minus alpha. Make sense? And what is this angle from say here? This is alpha. Okay. What is say this angle? This angle is 180 minus gamma, correct? And what is this angle? If you say what is this is alpha, observe here, if you see b by or sorry, a by a is this angle, this one is a, observe, a by the opposite to that, a by opposite to that, that opposite to that a is equal to 180 minus alpha, observe here, 180 minus alpha. Similarly, because this is 180, observe here, this is 180, this is a straight line over here, 180 minus alpha. Similar way, b, if you see b is here, the opposite to that, okay, opposite to that is coming from this particular thing till wait a minute students, okay, opposite to that comes over here, observe, opposite to that comes over here, this angle, and this angle is 180 here, observe here, this is 180, this is 180 minus beta, makes sense? Okay, so this is beta is equal to 1, b is equal to 180 minus beta. Similar way, c is equal to 180 minus gamma, observe, this is c is this one, so 180 is still here, observe, 180 is from say this particular point to this here, this line is 180, and minus beta is 180 minus gamma, so 180 minus gamma is this angle, is it not? So it is 180 minus gamma. So the same thing, instead of alpha, beta, gamma, from this we are getting this. I am happy. Okay, I hope you have understood this, students, although I took some time to make you understand. Okay, yeah, correct, students. So what is happening? From the triangle law, Lami's theorem comes. The base of Lami's theorem is triangular law. Okay, yes. Sometimes overconfidence on my side affects.
ಈ ಜೀವ ದೇವರಿಗಿಂತ ತುಂಬಾ
And students, come on.
Done, sir.
Very good. You have to tell me. Otherwise, I'll be simply sitting here. Okay. Next, we will see resolution of vectors. Okay. Next point is resolution of vectors. Resolution of vector. How to resolve vector into components. Okay. Now, what we generally do is we resolve in 2 dimensions. Let us derive in 2 dimensions first. So if I have a vector, say P, okay, now say this is alpha and this is beta, okay, so now the component of this in this direction, say in the I direction and in the J direction, okay, now this component, this is a vector P, okay? This one is called Px, which is the component of P in the x direction. This is called Py, which is component of P in the y direction. So always Px is equal to magnitude of P cos of alpha, and Py is equal to magnitude of P cos beta, which can also be equal to magnitude of P sine alpha, sine beta. This can be equal to magnitude of P. Why sine beta? Because this can be written as cos of, this can be written as cos of 90 minus alpha. Correct? 90 minus beta, I'm sorry. Alpha is 90 minus beta. Similar way, P of cos of 90 minus alpha. So what is this? This is P, okay? P sine beta, and this is equal to P sine alpha. Make sense? This is how we find the components. And P vector is always equal to Px cos alpha plus Py sine alpha, or okay, P vector is equal to, I'm sorry, this is wrong, students, okay? So it is always equal to Pxi plus Pyj. This is how you can write. Also, you can write this as equal to Px can be written as, if you want to write it properly, we can write it as Li plus Mj into P vector, P magnitude of P. Makes sense? Okay, it is Li plus Mj divided into magnitude of P, where L is equal to cos alpha and M is equal to cos beta are direction cosines, and Li plus Mj is the unit vector P, is a unit vector P, where P is equal to Pxi plus Pyj divided by square root of Px square plus Py square. Make sense? Make sense, students? Write this down. Done. So we will stop the class now. We will meet again at 11 o'clock. Okay? Sorry, 12 o'clock with another 1.5 hours of class on limits. Okay?
ಇದ್ದಾನೆ.
Tell me when you're finished, students. We will stop the class now.